All right, today. Only problem with this one, the battery runs out quick, so I might fly through this really quick. Blah, 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 blah. Okay. Uh-oh. There it is. All right. Andrew, can you be a kind gentleman and erase that cosine stuff at the bottom there? Okay, what we're doing today is we're going to work with second derivatives. Second derivatives, at the very basis of them, are super easy. So, as in this example up here, if I start out with x cubed plus 2x squared, and this is f of x, the first derivative of x would be 3x squared plus 4x. And the second derivative of this would be 6x plus 4. What about the third derivative of this? 6. What about the fourth derivative of this? Okay? Derivatives, super easy like that. But our second derivatives won't be so easy because we're going to involve the chain rule in some of ours and other rules. So I'm going to zoom in here because I can, unlike using that fancy pen. All right. So to find the second derivative, what do we have to do first? Find the first derivative. What's the first derivative of that using the chain rule? 5. Good start. Negative 5x plus 6 to the fourth power times negative 5. So the first derivative of this, and we rewrite it just so we're all on the same page, negative 25 times negative 5x plus 6 to the fourth power. Let me get a little bit skinnier pen here. Let's go like there. All right. Second derivative. Chain rule again. Negative 100 times negative 5x plus 6 to the third power times negative 5. So its final answer of the second derivative is 500 times negative 5x plus 6 to the third power. That wasn't so bad, was it? Okay, so let's do this one. Oh, this one's an easy one. What's the first derivative of that bad boy? E to the 7x minus 4 times 7. So the first derivative written is 7e to the 7x minus 4. What's the second derivative of this?
I have a question.
Yes.
Where did you get the 7?
Because it's the chain rule. You take the derivative of, so this is like e to the u. So whatever u is, you have to find the first derivative of u. Thanks, Taylor. So then when we do this one, it's 7e to the 7x minus 4, again, times 7, because that's the first derivative of the power. So our final answer on this would be 49e to the 7x minus 4. Oh, trig functions. What would the first derivative of this function be? Five. Negative 5 sine of 2x plus 10 times 2. So the first derivative of this function. See how I'm always rewriting the first derivative in a simplified format? That should be your next step after finding the first derivative. Now the second derivative. -10 cosine of 2x plus 10 times 2. So the final second derivative is and like Dylan says, this, or I don't know if it was Dylan, but these examples are always easier than what they have at Khan Academy. Oh, this isn't so easy. What's the first derivative of 3 to the x? That's when I pull out my note card because I don't always remember it either. Isn't it 3 to the x ln of 3 and there's a fraction involved somewhere? Or is it just like that? That's it? Okay. So then if we're here, Dylan, what's the ln of 3? No, what is the ln of 3? Just, it's 1 point something, 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 right? So it's basically like a coefficient of this, right? But let's just do the Dylan product rule now, just so we make sure we are all on the same page. So the product rule, we take 3 to the x times the first derivative of the ln of 3, which is? No, not 1 over 3. There's no variable in there, right? Dylan just told me that the ln of 3 was 1 point something, 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 something. What's the first derivative of 1 point something, 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 something? 0. That's why we really don't need the product rule here. Okay? Plus the ln of 3 times 3 to the x ln of 3, right? So you could say it's 3 to the x ln of 3 squared, if you wanted to, which is, okay, now we're getting into logarithm rules, 2 ln of 3, right? I don't know what format they'll have the answer in, but I would leave it like this myself. Okay? Second derivatives. Can we do them? Okay. Some of them might get a little harder. All right, second derivatives when we're involving implicit differentiation. Okay? Implicit differentiation. So, we're given the first derivative already is right there. Okay? Find the second derivative. Well, how do we find the second derivative? Well, that's just, what's the second derivative of this? 2x minus 2 dy dx. And then when I'm doing the second derivative, I'm going to replace the dy dx with what it is equal to, which is x squared minus 2y. And then I do the math. It's 2x minus 2x squared minus 4 or plus 4y. This is the second derivative if this would be the first derivative using implicit differentiation. That's not so hard, right? That was an easy one. Now, here's the original equation. We have to find the first derivative and then find the second derivative and figure out what the slope is of the second derivative at that point. So basically, we're working with concavity, which you haven't learned about yet until next chapter. But yeah. So what's the first derivative of this? What's dy dx of this thing? All right, so it's 2x plus 2y dy dx equals 0. So 2y dy dx equals negative 2x, because we want to get dy dx alone. Then we will divide by 2y. So dy dx equals negative x over y. First derivative. I want to find my second derivative. How do you find the second derivative or the derivative of just that? Well, it's the quotient rule. Y times the first derivative of negative x, negative 1, minus negative x times the first derivative of y. What's the first derivative of y? Dy dx. All over y squared. Minus a negative is? We're going to do that right now. So we got negative y plus x times what? Negative x over y all over y squared. Now, instead of trying to simplify that, you've got your point right here, right? Throw it in right now. Throw it in right now. So you got negative 3 plus 4 times 4/3 over 3 squared. Negative 4/3. Now what do we got? Negative 9 minus 16/3 over 9. In the numerator, what's my conundrum? You need a common denominator, right? So it's negative 27/3 minus 16/3 over 9. Where did the 9 come from in the numerator? What are you doing making a 9 there? It's all Calvin's fault. There. All right. How are we doing now? We're better? I think it looks a lot better. What's negative 9 minus 16? Negative 25/3 over 9. And then multiply both the top and bottom by 1/9 to get rid of that 9 on the bottom. So it's negative 27, or negative, come on, Mr. Bierschbach. Negative 25 over 27. Boom, 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 boom. That's the value of the second derivative of that function at 4,3. Anybody know what this looks like when it's graphed? Oh, you guys are so smart. It's a circle. It's a circle with a radius of 5. Okay? So over at 4,3, if we make a right, over at 4,3, I went more 3, 4 there. Over at 4,3, it has a radius of 5 there. See, right there, it's on the circle. And its second derivative would be negative 25/27. Its first derivative is negative 4/3. The slope of this is negative 4/3. Okay? And it's a negative there, so it's concave down. And we'll get up to concave up and concave down next chapter, I think. Let's do one more. Well, more than one more, because then we got to do disguised derivatives after this. But one more of these. Oh, geez. How do I take the first derivative of this thing? Wait, this is the first derivative. How would I take a derivative of that thing then? Product rule, 3x squared times the first derivative of y, which is dy dx, plus y times first derivative of 3x squared, 6x. So it's 3x squared times 3x squared y plus 6xy. So it's 9x to the fourth y plus 6xy. Oh, that was way too easy. I thought that one was going to be harder than that. Guess not. Because if we already have the first derivative, the second derivative is just the derivative of that. And yeah, that wasn't too hard. Okay. What is what? This is the difference quotient. The difference quotient is the limit as h approaches 0 of f of x plus h minus f of x all over h. Know this. This is like the Bible of taking a derivative, the difference quotient. All right. Yeah, you can write it down on your note card. That's fine. I don't care if that's on your note card. Now, you got to think a little outside the box on these. Okay? You got to go, okay, what is f of x? Well, f of x is right here. And then, so what is x? Well, what number does x equal in f of x here? 1. X equals 1. So basically, it's 6 times f of x, correct? Right here. 6 times f of 1, but 6 times f of x. So what is f of x? Well, our function is basically 6 tangent of, or 6 inverse tangent of x. Okay? That's the function that we see right here. Okay? Because it's f of x plus h, 1 plus h. So x plus h minus f of x. So f of x plus h is 6 arctangent of 1 plus h. X is 1 minus f of x. So we have this as our function. So then let's take the first derivative of our function according to our note card. What's the first derivative of 6 inverse tangent of x? Well, it's 6 times the inverse tangent of x is 1 over 1 plus x squared. So what's the first derivative? Oh, yep. What's the first derivative of that at 1? So it's 6 times 1 over 1 plus 1 squared. What's 1 squared? 1 plus 1 is? So it's 6 times 1/2, which is 3. That's what they call a disguised derivative. So what's f of x in this one? 2 times the cube root of x, where x equals 8. That's what you got to know. How we take the first derivative of that? Change it to 2x to the 1/3 power, right? So it's 2/3 x to the negative 2/3. Which is 2 over 3 times the cube root of x squared. Because x to the 2/3 is the cube root of x squared. And then when it's negative, it goes to the denominator. What's our number we're going to put in for x? 8. It's this one right here. So we're going to stick an 8 in there. So it's 2 over 3 times the cube root of 8 squared. So it's 2 over 3 times the cube root of 64. What's the cube root of 64? Cube root of 64. What times what times what is 64? 4. 4 times 4 times 4 is 64, right? So the cube root of 64 is 4. So it's 2 over 12, which is 1/6. Disguised derivatives. Hey, that's it. We're done. All right, so you have a couple of assignments. Well, there's like three little things to do, and then a quiz. And then on Friday, we'll review for the Khan Academy test, and I'll open that up. And then on Tuesday, we will review for the AP classroom test, and on Thursday, we'll take the AP classroom test. So that's what's coming up. Did I accidentally? No, that's quiz 2. There's a quiz 3. Yep, there'll be another one today.